This is Auburn Mattingly, Outreach Director for the Society of Women Engineers at the University of Kentucky. For our first experiment, we're going to be examining Charles's Law with a bar of Ivory Soap. So for this experiment, you will need a bar of Ivory Soap, and it has to be the brand Ivory because of the unique air content in the soap. So we're going to start by opening up this bar of soap and placing it into the microwave. So you all be thinking about what you think is going to happen when we put this bar of Ivory Soap into the microwave. You want to set your timer for about 1 minute and 30 seconds or 2 minutes, and you can stop it whenever you see what happens. So be making a guess. All right. What's happening? Can you all see it? The soap is expanding. Look at that. Whoa, it kind of looks like a cloud in there, don't you think? We're going to go ahead and stop ours. So that just took about 1 minute on my microwave, but it might be different on yours. Look at that. Do you see that one bar of soap? It looks like a cloud now. And look, you can feel of it and break off little pieces. So be sure to feel this at home and see how the texture even of the soap has changed. Now, that was a pretty cool experiment. And next, we're going to explain the science and the engineering behind why this happened. So let's discuss the engineering behind this now. Why did the bar of soap just expand and become like a cloud whenever we put it into the microwave? Well, this is actually because a bar of Ivory Soap has air whipped into it during the manufacturing process. And this high volume of air in the soap is what causes it to expand. So whenever we heat that bar of soap up, the water inside there will evaporate and become water vapor. And it's trapped, so whenever it's trapped, it expands. This is known as Charles's Law. It states that whenever we increase the temperature of a gas, the volume also expands. So that's why our bar went from being about this big to growing to like this big, like a cloud. In a solid, molecules are packed really tight together, but in a gas, they're further spread apart. This is why the volume of the gas was bigger whenever the ivory bar expanded because of the heat. As you see in this video, a real-life example of Charles's Law is a hot air balloon. In a hot air balloon, a flame is used to heat up the gas because, as we learned with Charles's Law, when a gas is heated, it expands. And when this gas expands, it becomes less dense, meaning that the balloon is lifted into the air. This warm air that has been heated by the flame is less dense than the cold air, which means that it's lighter than the cold air and has less mass per unit volume. That is what allows the hot air balloon to float. So, our little experiment with the Ivory Soap shows us how a real-life hot air balloon is able to fly in the air. Pretty cool, huh? That's the science and engineering behind video 1 of Engineering is Sweet. Be sure to tune in next time for our next video and upload your picture for a pretty sweet prize.